Hi, very good morning. I am RadhaKrishna Prasad, the trainer of this Advanced Performance Engineering program, and welcome to day two technical demo session. So, as part of this training program, every time we take up a new batch, we give two demo sessions. One is on the course content, how we are going to take it up, and how we are driving it. And the second demo is all about a pure technical demo. We'll pick one of the concepts, and we're going to explain you what is that we really teach. We'll make the participants to understand what exactly we teach and what is the way we teach with every topic that is part of our advanced performance engineering program. Okay. So today we would like to talk about something called uh, why performance testing and engineering projects fail. Okay. So be it any associate having 1 to 15 years of experience, people have to understand what is the importance of performance testing, performance engineering, and application performance management, which is going to talk about n number of tools available in the market, like primarily DynaTrace, then App Dynamics, then CAAPM, which is formerly uh, CA Wiley Intrascope, and then you have New Relic. And if you take the open source and commercial tools, there are n plus one varieties of tools available. Prometheus, which is going to monitor all the microservices based applications, and you'll have Zabbix. And if you want to monitor anything in specific, like you have uh, SolarWinds NPM, which is going to exclusively monitor network performance monitoring. So identifying the tech stack, identifying the technologies that are used for building an application, developing an application, and most importantly, from a performance engineering point of view, performance testing point of view, how is that we are testing the applications, for what reason we are testing the applications, understanding the bottlenecks. So basically, the most traditional approach, if you take many of the service-based companies, the most traditional based approach that we follow is you design a script, you build a error-free script by doing some custom coding, by reading some custom requests. You do all the error handling, then you do correlation parameterization. You create a scenario with some X number of users with Y duration, and you start play button. Okay. The question is, you will see different problems on all the performance testing projects. The main point is how to interpret the results, how to capture the recommendations, how to capture the performance degradations, and accordingly how we need to optimize them, improve them by touching all the different areas that are part of your infrastructure. And there are many questions. First of all, when I say performance projects, the most commonly answered question across many interviews that I have taken, what is the bottlenecks you have identified, or what is uh, the metrics that you have monitored? The first answer that I generally would get from many of the people who are from service-based companies with 3 to 5 years experience span, they say that we don't have we don't have access to the database server. Okay, we don't have access to the application server. That is why the reason many of the performance associates, they don't get a chance to take heap dump analysis, thread dump analysis, or GC log analysis. And many of the bottlenecks, like I said in the previous demo, 20% of the bottlenecks they happen from the web layer, 30% of the bottlenecks they happen from the application layer, and the remaining 50% bottlenecks are, I mean, majority of the bottlenecks. It may not apply to all the projects, but if you take many projects in common, majority of the bottlenecks, 50% of the bottlenecks, they happen from the database layer. Okay. So now, if I talk about performance testing failures, if I talk about how we are actually testing the performance of all the applications, okay. So are we doing right is the main question, because if you go back and recollect some 5 years back, there used to be a centralized teams, and there is a approach that is followed, like when only when the application is functionally stable, only when all the functional errors, bugs are sorted out, that is the best time to do performance testing. Now, if you look at the many of the companies and projects, there is an individual contributor role who has to take care of end-to-end performance testing lifecycle, engineering lifecycle, and he or she has to involve in each and every individual phase of performance testing life cycle and engineering life cycle, right from the non-functional requirement gathering till the sign off. So it is he himself or she who has to uh, collect the NFRs, which are also called BVMs, SLAs, or whatever it is. It is who has to create the estimation, who has to create the non-functional test plan, test strategy, and also all other activities that are part of a performance testing and engineering project, right? So if you talk from the point number one, projects involving in performance testing engineering fail for a variety number of reasons, okay? And the majority of the performance project testing projects and engineering projects fail because of highly complex reasons that are there from every phase of development life cycle and performance testing life cycle. And sometimes, right, these performance problems are also called known performance problems, hidden performance problems, which will be there continuously for years. That is the reason the response times of few particular transactions in an application will be always high, even if you do some continuous testing on all the applications. Okay, there are few performance problems that are uncontrollable and it's out of control of any project manager, technical architects, and also the performance engineers. The main point, if you ask about the performance testing projects failures, is about the people who don't understand the technical complexity of any project. For example, if you have a manager who don't understand anything technically, it would become so hard and so difficult for any of the performance engineer to make everyone to understand from where actually you need to start performance testing, what is the approach you have to follow, and what is the time that it is going to take for any performance project. Okay, so if you take this session, in my experience, from both business level and personal level, most of the performance projects, they fail due to simply lack of communication between the performance engineers, the developers, or the database administrators, and also the people from the business team who don't give complete information on the application, and especially the stakeholders who are not technically so good, right? If you have a client who doesn't know anything about performance testing, who is investing some money on the project and expecting some X response time with respect to industry standard, which is 3 to 5 seconds, it is again the responsibility of a performance engineer to educate, to communicate everything on what is going to happen from the project side with respect to performance testing to each of the stakeholders that are part of your project. Okay, these type of applications, these type of activities in all the applications, they end up causing many other problems which will directly impact the application performance and the return of investment. Okay, so for all this explanation, there is a question: what is that I have to do as a performance engineer, or if I am an individual contributor in a single project, what is that I have to do? So the only objective of any performance testing assignment should be so strategic, and you need to perform some effective performance tests for any application product, uh, so that you can achieve the satisfactory return on investment and good response times. Okay, and what people don't understand from other teams about performance testing is many of the applications, they are very risky and they always require a lot of trial and error method with so much of rigorous testing from the early stages of development. Now, if I ask you, from your experience, do you have any specific reasons for a performance testing failures? Or if you're working as an individual contributor, what are all the challenges or objectives that you have identified from any project? You can tell me anything. Anyone? Anyone can tell me why the performance testing projects can fail? Any specific reasons or from your experience? Basically, the failures, okay, that's okay. failures in PT, they must be in any project. Failures in performance testing of all the testing projects, they must be treated similarly to other business problems. It is very important to understand when you do any performance testing, right? What you do is, I'll tell you what is the traditional approach most of us follow. We get the NFRs straight away. You have a workload modeling ready, which is given by the client. Then you have a test scenario ready. You run with some X number of users for some duration. You have autocollate results option. As soon as the test is completed, you will get the results report, and you give the HTML format report of the average transaction summary, transaction performance summary, transaction failure rate, partial transactions, failed transactions, bits per second throughput by default. And finally, you will add something called errors and HTTP status codes in the report, and you send it. My question is, what is that you are missing in publishing the report? When you publish the report, most of us will miss to interpret the results correctly. Okay, so when you do performance testing, you will see n number of problems. It can be from the client side, it can be from the server side, it can be from the web layer, app layer, or DB layer, or it can also be from the other components like DNS server or CDN or load balancer. It can be because of the poor performance, can be because of poor load balancing algorithms, heavy client side. Most of us, we don't do client side performance testing, right? We don't validate the client side. You don't validate JavaScript calls. You don't validate the size of the images. You don't validate the CSS. So with the help of Google Lighthouse, as part of early performance testing, many of the companies has to do client-side performance testing, and they have to target the server side. And if it is an application which is completely of APIs and web services, before doing end-to-end performance testing, most of us, we don't do API performance testing or web services performance testing. Any API call across, if you have some 300 to 400 API calls in a single app in an application, one API call can completely degrade the performance of the entire application. So it is important to validate, it is important to understand, very essential to understand what went wrong, why it went wrong, and what can be done to prevent all the problems. In most of the scenarios, right, many of the performance engineers has to run a one-man show role, who has to take care of everything, right? If when I mean to say, a performance engineer who is in a team of a very sensitive application, be it a microservices based application, monolithic application, or if you take an application which is moving from on-prem to cloud, so he or she has to take a part of in every discussion to identify the performance problems, to understand. He or she has to make everyone educate, understand about all the performance challenges in the end-to-end performance full lifecycle implementations. So my personal experience working with practice teams and COE teams, I have seen the same mistakes repeatedly happening from multiple teams and projects. So based on my personal experience, I have a big list of what is that you have to avoid in order to uh, make successful performance testing without any obstacles or challenges. I don't say that you will not have any challenges if you follow this approach, but most of the things that I have observed in many of the performance testing assignments is, the first thing, unclear and incomplete NFRs. So people have to very much aware of the terminology that you have, because some people call it as SOWs. I mean, SOW is a different one, but some people in some projects, in performance testing projects, NFRs are also called as SOWs. Then they call it as SLAs, SOW, right? Statement of work. Then they call it as SLAs, which is also called service level agreements. Then some people call it as KPIs, which is key performance indicators. And the last one they would call as BVMs, which is also called business volume metrics. And finally, people call it as all this terminology in common that will be used as NFRs, okay, non-functional requirements. So If you take many of the projects, right? I'm sorry. If you take many of the projects, gathering non-functional requirements, complete NFRs is very complex. So if you compare gathering functional requirements and non-functional requirements, gathering functional requirements is so easy. And the most common mistake every company or project does is these NFRs when it comes to non-functional requirement gathering. Just a minute. Sorry. These NFRs, gathering NFRs is treated as second or even third class type of requirements. Okay. Similar to other requirements like functional requirements, these NFRs, non-functional requirements also, I mean, they must be treated as first class type requirements so that the equal importance will be given to all the requirements and they will be treated as priority. For example, when you don't get a single input from any of the team who is sitting across the project with respect to performance testing area, it would become so difficult to derive the conclusion on how efficiently the application can work or with how many number of users the system can handle so well. So deriving such conclusions would be so hard without the complete information from the NFR side. If you take some of the customers, they're going to take only they are going to give you one requirement. For example, there is one customer I remember who has given me, you have to achieve some 0.5 TPS or something. From there, it is the performance engineer who has to calculate the think time, who has to calculate the pacing, then who has to decide the test duration, and he should also decide what type of test we have to perform on the application. Is it load, stress, endurance, and with how many number of users is what you have to do it. So when these requirements are not completely gathered or in the project phases, if the NFRs are treated as second class or even third class type of requirements, as a result, many of them are missed. Okay, many of them are misunderstood, many of them are neglected, and there are only few organizations and projects that focus NFRs as first class type requirements. Okay, so these type of approach, right, they give severe problems in the system architecture, design, and user experience. So, and even if you take many of the projects, if you see, they led to project breakdowns, and if you can also see the website crashes like Chicago Board Options Exchange, and you have some applications like Obama's free insurance. After they went to live, within 30 minutes to 45 minutes of time, the entire application has gone down, right? So whenever you try to gather NFRs, right, you need to prepare NFR non-functional requirement gathering or client questionnaire document. I'm going to send you that document where you are going to have a list of docs, okay, which is going to tell you about everything. For example, I'll show you the client questionnaire document, okay? Okay, so if you look at this doc, or if you look at this doc, this is something when you don't have anything in place, there is something called performance testing requirement collection questionnaire or non-functional requirement gathering. They could be in different formats, but they could give you so much of information. For example, you're going to ask all these types of questions. What is the main purpose of testing the application? Where do you intend to perform this test? Is it on a performance environment? Is it in a dedicated QA environment? On a staging environment? On a production environment? What are the types of testing that you have to perform? Then what are the levels of testing? What is the need of continuous monitoring of the application? And what is the approximate timeline? Then steady state duration. We have a lot of questions. And if you can see here, the complexity of the scripts is also asked. For example, if you see, if a script is simple, it will have 4 to 8 steps. If it is medium, it is 8 to 12 steps. If it is high script, which is 12 to 20 steps, and very complex script, it would be more than greater than 20 transactions. So likewise, you're going to ask about the environment, how to set up an environment, the hardware, software configuration of all the web app DB servers in the architecture, and what are the other components that are part of. You can also see, we're also asking what is the client side and what are the browsers that are used for your performance testing, and we're going to ask the architectural diagram, application flows, end-to-end use cases. So even if you can see the information that we asked, web server, application server, we'll ask what is the type of web server. Is it a web, I mean, is it an IIS or is it an Apache Tomcat? When it comes to application server, is it an WebLogic server or WebSphere server? And database server, you're going to ask, is it a SQL server, MySQL server, Oracle, Cassandra, Postgres, any other database? So it depends on what is the application type. Is it a Java application? Is it a .NET application? So if you can see, we are also asking the information of processor, clock speed, number of processors, the memory, if it is load balanced, how it is balanced, all these things. What is the type of disk? What is the disk capacity? So there are similar ways of asking the information from the software. This is hardware information. So if you see the software information, you're also asking the OS of the web server, the configuration settings that are set before you run the test. You're also going to ask which SSL certificate, the version of it, the expiry date of the SSL certificate. And if it is encrypted, you can also ask the number of bits of encryption, etc. And you're also gathering the versions of all the softwares that are installed. You can also ask the network information, the protocols, the load distribution part. And finally, you're going to ask all this information. This is one type of document, and this is another type of document. It could be different, but as a part of non-functional requirement gathering, you can consolidate all these points and you can put it in one document, and you can send it to all the team members who is sitting across the project. Okay, so you're going to ask how many users, out of which how many of them are typical users, how many of them are concurrent users, what are the critical business transactions, regions, defining load generators, load generator configurations. All these things are something which you should be gathering as part of non-functional requirement gathering. So if you want to be successful in any of the performance testing project, a solid NFR document is what you should create. So that NFR document should contain all this information to get all the NFRs in detail, and it has to identify all of the criteria of that product, of that application. And this type of NFR document or non-functional test plan is something which we have to create to be successful in production with best performance. Okay, so for that you have to establish clear performance goals, and you should have the expectations for the product, application, and the system. And second point is you must get everyone, I mean, you should be in sync. The performance engineer has to he or she has to have the negotiation skills, the soft skills, the communication skills, who has to interact with the development teams, admin teams, or database administrators, business teams, and stakeholders. And you all should be on the same page. Every information, every point of NFR should be gathered from every team. If it is for example, if it is an optimization from the database, you have to clearly ask the database administrator, are you fine tuning the SQL query or a stored procedure which is taking some 13 seconds of time? If yes, how did you tune it, and how that improved the performance of the application from the current run to previous run? Any bottleneck that has been fixed, you need to collect that entire information from the respective team to let the customer know about how the performance optimization has done and what is the percentage of performance improvement happened from the current test run to the previous test run. You have to correlate that result, and you have to publish the clear differences detailing the bottleneck fixed? What fixed the performance degradation? And right, fixing the performance degradations would take months, sometimes years. Okay, no doubt about it. It would take so much of time because there are a few scenarios, like there are some applications which are legacy applications. Okay, so what they do is the customer will not allow to touch the code. Okay, majority of the bottlenecks again they are from the source code. If you don't touch the code, if you don't do code optimization, if you don't know what each and every individual line of code is spending time, how much time it is spending, be it a method, be it a function, or be it some object who is which where it is eating lots of memory. That is why the reason you are taking heap dump analysis, right? How what objects are doing, how the objects are allocating memory. That is what heap memory is all about. When you come to threads, how efficiently the application is handling, how threads are being utilized, what is the concurrency of the application, to what extent I can scale up the number of users with the number of threads available in the thread pool. Is there a resource contention? Is there a deadlock? Is there a lock on a specific object? All these things are identified with the help of heap dump analysis, thread dump analysis, and GC logs. How efficiently the GC is deleting all the unused objects, unreferenced objects, right? Dead objects. So all these things you should talk to each and everyone, and you should understand what fixed the problem, who has fixed it, and you need to have the detailed information which you need to put that in a report where you have to educate the customer. You have to tell the customer what improved the performance. So that is the reason you have to build communication between technical teams, project teams, and business teams to understand the real performance problems of all the end users in the production. And second point, many of us don't do workload modeling, right? If the customer is giving it, we straight away create a scenario. But every performance engineer should know how to do workload modeling, because there are applications which are not performance tested earlier. It is the first time you're doing performance testing on an application which is already there in production from the last 5 years. You need to have some efficient approach, right? Single point. If your workload modeling is wrong, whatever you're doing in performance testing, whatever you're validating, it's all waste of time. I mean, it will give you inaccurate results, and it will give you, I don't say wrong bottlenecks, but inefficient results. You need to give the right workload modeling. If you take any application like Gmail or Yahoo Mail, how many percentage of users are really clicking on a functionality called can't access my account? If you're giving 30% of the workload, I mean, in the maximum handling capacity of the users, in 100 users, you're giving 30 to 35% of the users to that particular functionality is of no use. You need to understand what is the percentage of activity that is going to happen from the end users on that specific functionality in an application or a product. So for that, if you want to get the production logs, if you want to understand the real traffic in production of any application, you need to understand the architecture. You need to understand the design of the application. You need to understand the existing issues of the application, hidden performance problems of your application, while collecting non-functional requirements. For that reason, you can use tools like Alexa or Google Analytics, and you can also use like SolarWinds Pingdom and OmniTure. Do you know what these tools are for? These are site analytical tools. Basically, they're going to get all the production traffic statistics, which will help us to create the effective workload models. Okay, so non-functional requirements, again, you should start discussing this NFRs from the start of software development process, and throughout the software life cycle, you need to continuously get in touch with the developers to do baselining, benchmarking, And baselining benchmarking is necessary for any application for performance testing if the application is brand new. Okay. And what many of us do is in the NFRs gathering, we don't get the complete information. You should get the complete information. When I say the complete information, no one is going to talk about the internal external components that are involved in an architecture. You are only looking at the application side, but there is an application which should have some infrastructure, and that application will have some architecture, right? You should understand, even though if you're a non-technical, non-functional, you belong to non-functional testing, it is very important for everyone to understand the application technically, functionally. Okay, so you should get the complete information of all the internal and external components involved. Sorry. And you have to clearly understand how they communicate. For example, you are doing performance testing on an environment where you will not have a CDN. Some performance testing environments, they don't even have firewall. Some performance testing environments, they don't have load balancers, like in real time, like prod environments. Some of them will not have DNS, right? And some of the environments, they don't have properly simulated networks. They don't have cache policies enabled at all the layers of servers, but you still do performance testing, right? Is that valid? You're not doing performance testing on an environment which is not same as prod. You're doing performance testing on an environment which is 1/4 size or 1/8 size of your production environment. But do you think that results are valid? Or my second question is, how do we extrapolate the results? The production has the capacity of handling 1,000 users, but whereas you're testing 1/4 size of the prod environment, which is QA environment or performance environment, where you can test only with 250 users. So whatever the results that you get when you test with 250 users on dedicated performance testing environment, which is 1/4 size of prod, can you tell the customer that when you test with 1,000 users, this is the performance that you're going to see on prod? Can we extrapolate like that?
No.
Right? So definitely not. So for that, you need to get all the information of the internal, external components, how the communication is happening. You need to understand the role of CDN. You need to understand the role of protocols, the list of protocols, the load implementation, the firewall's behavior, the load balancer. Some of the applications will have proxy and reverse proxy servers. You need to understand the concept of every component that is part of your architecture and infrastructure, which is responsible for performance degradation, not today, but sometime tomorrow. The cache is not implemented. You have cache policies, they are not implemented. A simple example is the database that you have on prod, the database you have on performance testing environment, they are extremely different. The activity that is going to happen on a production environment, 25% of the activity on QA database is not there like in prod. Because like I said in the previous session, the database in your performance testing environment, it becomes active only when you test it, only when you trigger something. But whereas a prod database, it will have some shared applications, it will have some backups running, it will have some recoveries running, it will have some batch jobs running. That is why the reason the resource utilizations, if you note it on production database, it would be some 70% CPU utilization, whereas if you go and see the performance testing environment, when you run it, it is only 17% of CPU utilization. 50% is difference, right? So for that reason, you need to understand the application footprint. You need to understand internal, external, third-party components, and also you need to understand the architectural limitations. For any application, you have to consider the breakdowns of your business objectives into system requirements with the performance testing. So Uh, for example, I would like to show you a simple thing, but this is very important for everyone's understanding. So I'll show you this thing. So, so when I say you need to consider the breakdown, right? When I'm saying considering the breakdown, okay. So if you look at this one, right? For example, workload analysis and translation. What you need to understand when I say breaking down something into business objectives into system requirements. When you send a web page request, right, to the server, you need to understand the background of that request so that you'll understand the percentage of work activity that is being done on web app DB servers. So when you send a request here through the browser, it is going to send, you can see, considering an example below, a web page request for details of a customer. When you send it, when it goes to the web server, it is going to send two HTTP requests to the web server, one for the core page, which is a JSP, one for the image. Okay, there are two HTTP requests that are processed on the web server. Okay, then if you go to the application server, there are two requests that are sent to the application server, invoking two methods. Okay, and when it comes to database server, it is running two SQL queries on the database server. So you have two HTTP requests here on the web server. You have two methods that are running on the application server, and you have two SQL queries that are running on the database server. Anything from here of this particular request can increase the response time of this particular transaction to 10 seconds or even 15 seconds or greater than 30 seconds. So you have to optimize that HTTP request, or you have to optimize the method on the application server, or you have to fine tune, or you have to optimize the SQL query on the database server. So that is the main thing that you have to understand. So for that reason, you have to understand the application footprint, talk to the stakeholders, business teams to understand the goals of your application, and you have to identify what is essential. And you have to, in particular, you have to take some extra care on the existing legacy system performance problems, platform constraints, and other competitors in the market who are doing very well with respect to performance. For example, there is a competitor for Redbus, right? Abibus is the competitor. You have EaseMyTrip and MakeMyTrip. There are two competitors doing the same thing, but which one is so good at performance? That is the question. Okay, so the workload modeling. Then the other problem why the performance testing projects fail is because of managers and stakeholders. I don't say they directly impact, but they can do their best at failing the projects. The reason is, if your managers are non-technical, if the customer is not understand, he doesn't know anything about performance testing, they don't understand anything. That is the first point. Okay, managers or stakeholders who doesn't understand, or who don't listen to end users who have already expressed strong concerns about production performance. Okay, so people are directly complaining that we are facing a lot of issues in production. They are nothing but end users. So performance engineers or any other teams who are working in a project, they should continuously talk to the end users. And that is one thing that can completely reveal the existing performance problems that no one is aware of. To understand the existing performance problems, right, in the production systems especially, we need to get in touch with the end users, and we have to get continuous feedback from the end users on how the application is working or behaving under different anticipated load conditions. There are always n number of users use some feature in production, even though it would not meet their expectations with the desired performance, or if it is not working with the standard response time, they don't question. And many of us think that it's correct at that point of time, which become a bottleneck later point of time when you access it again. So anything you suspect, anything you assume it as a failure, you have to report that immediately. You may think that it is taking time, but it is loading. No, don't ignore. If it is taking time when you access the application manually, you have to report it. You need to ask the development team to do some code optimization using any of the profiling tools like JProfiler or JProbe, JMC, JFR to see how much time it is taking. If it is a .NET application, you should ask them to use DotTrace, JetBrains DotTrace, or YourKit Profiler. YourKit Profiler is also there for .NET, or you can also ask them to use Redgate Ant's Memory Profiler and Performance Profiler to see which method, which function is the problem in that page, in that web page. So if you want to improve the performance of the application, we must involve the end users to receive continuous feedback on the applications or system performance in production. It takes lot of time, lot of effort to interact with end users. I completely understand, but that is one of the best way, and it is definitely worth doing, and it is going to give you extra value of delivering the greatest performance of your final application or final product, right? So, and the other point is poor architectural design. So sorry if I'm talking all the other stuff which are not your part of, but many of the companies' expectation nowadays with the emerging performance testing, engineering, and testing trends is asking for all these areas. When your architectural design is so bad, everything is bad. Initially, in the initial phases of performance testing, poor architecture will cause only minor problems, which will be very less at the beginning. But they start to add up, okay? They will add more and more problems. Simple maintenance is always a challenge, and any change in one area can break all the other parts of the application and system. For that reason, I always keep telling my team to continuously bug the developers. The main problem is if you're running a test today, you are running a test tomorrow, you are running a test day after tomorrow. After 3 days of continuous testing, on the fourth day, you are seeing some unexpected behavior in the application with respect to response times in other transactions. If the change that has happened on the application from the dev side is not communicated with performance testing team, it would be very hard and difficult for performance engineers to find out what went wrong. Every change that is happening from the development side with respect to source code or from the feature side has to be communicated to all the performance engineers so that we can easily assess, correlate, and understand the differences in response time from multiple test runs. Most of the major roadblock of any project, performance engineers, they don't get information on the change that has happened from the developers. Performance engineers say that the developers are not communicating. But how about performance engineers? It is the role of a performance engineer to continuously talk to the developer, and you have to continuously ask him on what is the change happened, right? It is definitely a responsibility of a performance engineer to continuously ask the developer to understand what is the change happened. Only when you get to know the complete information of what change that has been incorporated from the last test run to the current test run, you will easily understand what are all the other areas that are performing bad. So for that reason, your application, if your no changes are communicated anytime, any application, any system could experience severe performance degradations. If your network is bad, if you have excess network latency, and if you have other issues, and performance engineers or non-technical managers or the customers, if they're making inappropriate decisions during the architectural design phase, the entire team will suffer during the complete development during the development phases of the application, testing phases of the application. during the maintenance phases of the application. So architecture should be so strong. Performance engineers need to understand the application architecture blueprint that is going to organize and which is going to help which is going to help to conceptualize the system behavior. I mean, with what I mean to say is, with no understanding of a clearly defined application system architecture process, you will see high risks of having too much uncertainty, and you will see a lot of complexities during the load test execution phase, which can give you more unintended performance problems for all the performance testers. Okay, so and you also need to look at unforeseen technology dependencies. If you don't understand what are all the technologies that are part of your application, you will fail to identify the bottlenecks and fix them, right? Dependencies, right, they are the connection between two components which are going to allow for more application features, functionality. So for that reason, you need to understand the feasibility of the specific OS versions. If you take Linux, be it Red Hat, Ubuntu, CentOS, you need to understand the application servers, database servers, JVMs, if it is a Java-based application. You need to understand CLR, Java Virtual Machine for Java applications, CLR, Common Language Runtime for .NET applications. You need to understand the .NET framework. They are simple dependencies for in all the applications. Okay, so the dependencies sometimes they can be more complex if you are running everything in Linux, especially for Java, or if applications are using some scripting languages like Python or Ruby. So understanding each technology dependencies on each component in terms of design and infrastructure, understanding which technologies are used, what frameworks are used, what are the tools that are helping these frameworks to develop the application. So it is critical for understanding all of these things are very critical for performance engineer to accomplish the desired results. Okay, so before starting performance testing, many of them they don't have clear performance goals. Whenever you're doing something, you need to have an objective and goal, right? So for that thing, you need to have goals. Without goals, don't start anything, I would say. Setting goals is one of the most important aspect for every performance engineer success. Many performance teams, right, will constant they do they repeatedly do the same mistakes again and again. They fall short of their performance goals, or for improvement they spend lots and lots of time on the known performance issues or existing performance problems or hidden performance problems. So perfect goals, objectives of any performance testing project has to be defined. They should be appropriately designed, and they should be performed in the most realistic conditions. You need to use the real browsers, you need to use the real devices, and you need to simulate the real network simulation, hardware virtualization, or if it is being accessed globally, you also need to set the multiple geographical locations. And what you do is, most of the people say that we don't have cost, we don't, it's an extra investment to spend on the monitoring tool. Monitoring tool is definitely not an investment. It is the heart of any project. So for that, determining the right metrics to monitor, what kind of performance we are measuring, defining the minimum thresholds of, for every metric. And that is when we are actually running the performance, executing the performance tests with baseline results, and all the results with these figures are necessary to determine what changes can actually create or achieve the performance improvements. Okay, and remember that it is always a very good practice to start performance testing from the early development cycle, early development life cycle. You have to start performance testing as early as possible in the software development life cycle to eliminate all the bottlenecks in the first place. And you have to make sure that it is constantly checked for performance under heavy load. Okay, and I also said, right, with the help of agility, with the help of agile and sprint based approach, What they do? You have a very limited timeline, but still the development team, right? They want more from you, not the development. I would say the customer. So just to, for the sake of customer, adding a new feature or doing some change in the last minute of every release will put everyone into red. So excessive feature expansion is a common issue. I mean, it's a repeated committed mistake from every team, especially from the non-technical managers who don't understand the timelines, who don't understand delivering the quality product, quality of the application. Adding the feature is easy, but giving the quality of every feature is so important with desired performance. That is very, very hard for any one of us. So excessive feature expansion is a common issue that I see from every team. Every software developer, every performance engineer will have a very nightmare, very bad nightmares, and they have so many bad experiences just because of adding some simple feature in the last minute of every release. Okay, for that reason, you have to, I mean, constantly perform customer development meetings, and you have to initiate a discussion involving every team member to validate each feature. I mean, it actually happens from the development, but you should be a part of it so that you can meaningfully address the problem. If it is, what happens if you're adding that in the last minute, or if you take it to the next release, what is the advantage of having it? You can clearly explain it to everyone. Okay, so performance teams, right? Engineers have to start by planning the test environments. They should know the release schedules, and each one of you has to proactively communicate how much time it is going to take to test the application from the application front, from the performance front. If in case any new features are added in the last minute of every release, okay? Because many of the projects have their fixed timelines, right? Many of the projects have fixed deadlines. For that reason, you have to plan your environment requirements ahead of your schedule. So if you are not planning ahead of the project schedule, the timeline schedule, it is going to give you unexpected development delays, unexpected environment delays that are going to affect your performance testing schedule and timeline again. Okay, and if this is the way developers, DBAs, architects, business teams continue to add features in the last minute, it will definitely affect the quality of the deliverables, and everyone in the team will automatically suffer. But everyone knows it. So ultimately, the customer, what they do is, even if you feel it as a new feature that you are adding in the last minute with no proper development, no proper performance testing is done on the application with the timeline just you have, ultimately the customer is going to reject the final deliverable. That is going to happen. So which will create a scenario of rework and additional resource shortages. You need to hire some extra 2 developers, 1 performance engineer to complete the task again in another 3 days. So the planning is so important. Understanding what is required for this release is so important. That is why the reason performance engineers should have excellent communication skills, negotiation skills, soft skills to educate, understand everyone the importance of performance testing and the goals, challenges that we face in our daily basis. Performance is not so easy. Performance cannot be achieved so easily, right? It is achieved only with the teamwork. Everyone has to collaborate. Everyone has to do their best, at least to fine tune something to improve point not 1% of performance. That is a part of someone's job. It's not the performance tester or engineer's job alone. Okay, and these are some of the shortfalls of all the performance engineers. Now, if I go back and ask many of the students when I interact in open sessions and tech talks, they say that we don't have access to the databases, we don't have access to the servers, we don't do capacity plannings, we directly get the NFR document, we directly get the workload modeling, we don't get access to talk about the architectural design, we don't get the complete information of the application. Yes, there are few applications like that, especially in the banking. Many of the clients, they are not supposed to disclose the architectural framework. They don't disclose it, but they can explain you what is what. At such situations, it is very difficult. But again, it is the complete initiation from the performance engineer who has to report everything to the manager. For everything, send an email, talk to the customer, and you need to tell all the possibilities, merits and demerits of having what and not having what. That is how it makes you a good performance engineer, right? So capacity, when I say capacity planning failures, right? When it comes to scaling, every time 90% CPU utilization on the database server, it doesn't mean that you have to increase another memory slot. Every time excessive disk utilization, it doesn't mean that you have to increase another disk or another instance of the database. The first thing is you need to look at the problem. You need to understand what went wrong, why it went wrong. Then you need to find a solution for that fix. You need to try optimizing that. If that is not fixed, there is other team, operations team, server administrators who are going to decide if they have to do vertical scaling or horizontal scaling. There are various reasons why infrastructures fail when you implement effective capacity planning. You know, everyone knows this, right? Capacity planning process is not simple and straightforward. We have to create a scenario. We have to add a traffic like in real time. We have to evaluate the results. We have to resolve all the performance problems, and you have to keep repeating the same thing until we are satisfied. But you still see the actual performance problems with poor capacity planning. Okay, so if you have poor capacity planning, it is going to increase all the risks. It is going to give you all the false results. So careful capacity planning is key, and capacity planning is a different science, which we'll talk later in this program. So system analysts from the infrastructure area, database administrators from the database area, programmers from the application development area are three different groups who need to be most involved in effective capacity planning process, and also the performance testing team as well, because performance tester is the one, engineer is the one who is going to validate after effective capacity planning is accomplished, right? Many of us again sometimes confuse with capacity management and capacity planning. These two things are different. Performance engineers along with other teams, just for the reason we can't forecast the loads accurately, and just for the reason of predicting wrong future workloads, everything is going bad with respect to performance. That is why the performance engineers, we have to ensure that we identify the accurate resource requirements, CPU, memory, disk space, network, to support the current and future workloads to meet the business demands. To avoid the capacity planning failures, you need to do continuous monitoring with the right metrics, which will help you to do methodology. Sorry, effective capacity planning, and it will also help you to tackle all the unexpected future workloads with increased traffic. Okay, so the last two things are, one is no methodology. Most of the client's expectation assumption, I hired a uh, skilled performance engineer, he can do everything is what the customer's expectation. We agree to the point that every performance engineer should have some experience in scripting language or development language. He or she should have a minimum 6 months to 1 year experience of development, or 25% of the concepts of web server, application server, and 30% of the concepts of database server are required, right? So basically, the assumption of every customer, every team is, I hired a performance engineer. I get any problem from any area of my infrastructure architecture, my performance engineer is going to do that. I would say, I don't say yes, I don't say no for this question, but the performance engineer has to initiate everything from his side. He has to ask each and every single point of failure from the respective team, be it web servers or application servers or database servers, or from the client side or from the CD and load balancer. He or she has to go to the right point of contact to understand the problem, and he has to ask the solution from them, and he has to rerun, repeat the test to see how the performance has improved. Just due to lack of methodology, proper methodology, or having no methodology, it is very, very difficult to get effective performance test results, right? Creating a, you need to have a plan, you need to have goals, you need to have performance test strategy, you need to have its coverage. So understanding the performance methodology, the process, which will help every performance engineer on the team, especially when you see so many performance problems. It will help you to provide the right fix for each bottleneck that has taken place. Okay, performance testing process, it should be well planned, it should be well defined and well documented. I always say good documentation is something that is going to build efficient communication between the developers or DBAs or performance engineers. If you see the latest applications, latest market trends of developing applications, testing applications, they have become more complex and multifaceted, right? And with growing more number of platforms, it has more number of locations. Uh, we have more number of platforms, locations to test. So it is important to have a robust performance testing and engineering methodology for ensuring that software applications or systems are being developed or have fully been tested to ensure that we meet the specified business requirements, and we are successfully operating with all anticipated load conditions on all environments with the required performance and capacity. Okay, so the last point of this session, address all the performance issues. Okay, when performance issues are not completely addressed, you see more and more performance problems. When we have increased number of users on the application, you will see more problems. Hidden problems are something which are bad, very bad. Known performance issues, you know the problem. And if you say that if you touch that problem, it is going to create a a lot of rework for the next release, you should not ignore it. When you have known performance issue, you should start working on it. You should explain the importance of all the performance issues that are going to happen in this release and maybe in future. So hidden performance problems, known performance issues in the applications are the primary reasons for continuous degraded performance. Every bottleneck identified, it has to be discussed with each and every team member in the project to successfully ensure performance with all the customer SLAs that are given from the stakeholders in the form of NFRs. When it comes to performance problem, every minute counts, and if you're ignoring existing performance problems or hidden performance problems, your applications and systems will become significantly slower, and it can even go to worse state. For example, right, some services might stop functioning on a heavy overloaded server, and all the applications, we can't access them. So we don't want to lose time finding out what your monitoring data is trying to tell you if a critical service is down. For that reason, you need to be very well aware of all the detection methods, and you also need to know the most common causes of all the server performance problems, because many of the problems they happen to see from all the web app DB layers. Okay, so this is all about something why performance testing and performance engineering projects fail. Like I keep telling the same point, a good performance engineer must be a good developer first, right? So performance engineer's job is so wide. Okay, it's a continuous learning technology. Even if you have it for the next 10 years or 15 years, the trend of performance testing would change with the recent involvement of AI and ML performance testing on IoT, AI and ML performance testing, the microservices applications, chaos engineering, residence engineering, then site reliability engineering. These are all the extensions of performance testing and engineering, where we always need to keep all the services and all the services up, and you need to keep that going. Okay, so one has to understand the problems from all the different areas, and he or she has to initiate everything from on his own, from his side, to successfully accomplish the desired results for any performance testing environment. So that's all for today. Thanks all of you for joining. Thanks for your time, and it's so nice of you and nice meeting you all. The new batch for this advanced performance engineering regular sessions would start from Wednesday, June 29th at 7 a.m. IST. Thank you.
Okay.